It's a waxing gibbous phase moon tonight, and you know what that means. It's One Moment's Nerd Out time! What's up, you guys? Happy Carb Week Day 2 and happy When Wellness Nerd Out time. So what we're talking about today is the chemistry a little bit behind cellulose and starch and glycogen, right? Some different polysaccharides as we mentioned yesterday. And let's get right to it. We're not going to make it too complicated. You know, for those of you nerds that are interested, it should still be enough depth, all right? So first, let's talk about the structure of glucose, because all three polysaccharides aforementioned are long polymers glucose, right? They're long linkages of a ton of different glucose molecules bound together, right? And so when we talk about glucose, picture a hexagon, right? So picture those 6 carbons, all right? 6 carbons bound together. Now, coming off of the first carbon, you can have what's called alpha or a beta bond, right? Configuration, alpha or beta configurations. And when 2 glucose molecules are bound together, you can either call them alpha glycosidic linkages or beta glycosidic linkages. So what's the difference? So when we talk about an alpha carbon in glucose, it means the hydroxyl group, or the OH, aka oxygen bound to hydrogen, right? The OH group is pointing down, okay? So when we talk about beta, it's the opposite. It's pointing up, is the hydroxyl group off the first carbon, okay? So what's the difference? Well, the big difference is when there's alpha ones linking up and when there are beta ones linking up, it's easier or more difficult to break down. So let's talk about which ones have which. So when we talk about starch, right, we have amylose and amylopectin. And those are both just 2 differently configured branches of glucose or sugar, right, that make it up. So when you talk about kind of the backbone, the straight linear part, that's our amylose, right? And our amylopectin is kind of branches coming off that, okay? So solid line of glucose, branches that are connected, okay? Starch, right? Amylose, amylopectin. When we talk about cellulose, right, and we talked about how you can't digest it, it really is just fiber to us, insoluble fiber, right? You eat it, it's just coming right out, you know? Kind of analogous to eating sawdust, if you will, right? Then, not exactly the same, don't hold me to that, but you get the principle. When we talk about the chain in cellulose, it's also a linear chain of glucose, like amylose, the backbone of the starch, right? But the difference is we have beta bonds between these glucose, okay? And since there's beta bonds between the different glucose in our cellulose, it means that one is like this. The next glucose is like this. The next is like this. So they're perpendicular at 180-degree orientation. Seems like that would be difficult to break down, and you're right, people. It sure is. That's why we can't. But when we talk about amylose and starch, they are alpha glycosidic bonds, right? So again, it's the OH group pointing down off the carbons, and more importantly to remember than that, or to just give you an idea of what's going on metabolically, that straight line is not oriented at 180. It's just so we could cut it down easily, right? And so, fun fact also, when you ever heard of amylase? Well, amylase, anything ACE, right, is an enzyme that breaks down that thing. So amylase breaks down amylose. And now you know that amylose is our linear polymer of glucose in polysaccharide, rather, of glucose, consisting of a bunch of polymers, in starch, right? So that's the fun little fact. Now, when we talk about glycogen, what's the difference? Well, glycogen, you know, if we can make glycogen as animals, right? We store glucose as our glycogen, right? And we can break it down. Well, wouldn't you think that it would be easy to break down? And of course, you know, so when we talk about glycogen, it's just all branches. The most branched. It's the most branch of the 3 polysaccharides we're talking about today, right? Starch and cellulose being the other 2. And so it's the easiest to break down And doesn't that make sense, people? So that's your little quick chemistry gist for today on carbohydrates. Short and sweet, baby. You know how it goes. Every day. So that's what we got for you. Tomorrow we're going to talk about something else, and we'll see what that is tomorrow. So it's going to be related to carbs. We might actually, we might talk about the timing of when you should eat carbs. Maybe we'll get into some foods and talk about, if you're somebody who fasts, when you should have them in relation to working out and burning calories and building muscle, right? Along with protein, of course. With different diets, different frequencies in eating, we'll obviously want to have them at different times for optimal benefit, folks. So that's what we got for you today. I hope you enjoyed it. What's up, Mel? What up, Nadia, M. Domino, and Bertha Flores? Thanks, you guys, for hopping on. I hope you enjoyed it. I hope it was informative. Hey, I'm glad, Mel. That's great. I'm really, really happy to hear that. I'm glad you're getting something out of it. Thank you very much. Fantastic quick discussion, and we'll see you tomorrow, folks. Happy Wend Wellness.